think it's a good time to start.
If there are no objections, all right, with no objections, we'll go ahead and get this thing started. Robot news, we got any robot news out there? I've scoured the headlines and come up with a few pieces. I'll put it in the chat here. It seems Toyota Research Institute has come up with a ceiling-mounted home robot. Let's see here. Oh, yep, before we go, let's start the record. Oh, you got the record going on, right, Dan? Hey, Jim.
Yeah,
it's a
it's on.
yes.
It's on.
The
I'm
recording's
not
on,
making
all
the
right.
same mistake again. I put it on automatically record. So we're good.
Let me post this article here. It seems that the Toyota Research Institute has they've created a ceiling-based arm robot, and oh, it's got a soft gripper on it. I think there was some talk on the mailing list about that. A soft bubble gripper, they call it. It's kind of interesting. And let's see, there was a dollar amount mentioned here that I thought was interesting. The past. All right, well, you can read that at your leisure. So there's one piece of robot news. Also, somebody who's done a demo here, Luke Keys, with his robot. Yeah, Thomas, can you get that story about the flying Amazon camera? I think I posted that on the mailing list. So
Camp, is that what you're talking about? Michael Sudano?
Is that the Toyota Research Institute?
Yeah.
Yeah.
He's a club member.
Who's that?
Michael Sudano.
Oh, I know that guy.
You remember him? He's Toyota
that guy.
Research Institute. He was going
Okay.
to Hacker Dojo and
Yeah.
was,
Well, he's
was
smarter than he
writing,
looks,
spoke
huh?
Japanese and was interested in robotics.
Yeah.
So he hosted SV Ross at
Toyota Research Institute.
Valley Robotics at Toyota Research Institute.
Yeah.
I was working with him on Stanford on the human assistant spot, and of course all that has been placed on hiatus. University worldwide, it just went into stasis.
Is that the one they had the pointer? You'd point at things and it'd go pick it up, for example?
They had a number of things. We were working on the last challenge. And that's interesting. They do things by challenges. And the last challenge was picking up several items and putting them into a square hole. One of them was a rope that you had to get into a very narrow, and of course, Patrick and I figured out they didn't specify how big the hole. They specified how big the hole was, but they didn't specify the shape. So instead of a round hole, we made a square hole because we had a longer diagonal.
There you go. Finding the loopholes.
Yep. Hey,
another
HBRC
piece.
all the way.
I've shared another article there. Somebody who's done demos with our club before is Luke Keys out of Austin, Texas. And his theatrical robot, Artie, is handing out trick-or-treat candy. So he was actually on ABC News, among other things. So that one's been in the news. And let's see here. Also in the news, I read that Helen Greiner's been named the CEO at Turtle. Turtle's that gardening, weeding robot that I think's been posted in the mailing list. That was kind of interesting. And then finally, Bear Robotics, they've renamed their serving robot Servy. Used to be named Penny. And apparently, of course, they've got, I think, $30 million loan from SoftBank. I think that was back in January. But they're apparently going into Japan big time, lack of servers there. So, of course, the Japanese society are more accepting of robots. So that's a good thing there. But so there's a couple of robot business. Oh, you posted the article on the flying Amazon drone security camera, I see. Jim, you posted that. Did I read, there was also an article out, what do they call these things? The Twilights or something? Anybody read that drone that, and maybe this is old news, but it follows you around when you're out jogging and stuff like that?
I saw that one.
Pardon?
Yeah, I saw that one.
Yeah, that's kind of
Pretty
interesting.
cool.
Well, what's the deal on this Amazon flying camera? Is it just a ring on a drone?
Well, I have the video queued up. You want me to share my screen?
Please.
Okay, let's see if I can.
Hey,
Oh,
Dan,
You have to
yeah, can you
enable
get
it.
Thomas to, can you make Thomas a co-host or whatever to get him
Yep.
to the screen?
Okay, should be on now.
Try it again. Oh, there we go.
This is Thomas Schmidt. He's
There it
with the Robotics Society of Southern California.
Okay, you guys see the screen?
Yes.
Yep, we can see it.
Okay.
Oh, yes.
Oh, yes.
Did you hit
You
play?
might need to click on play.
It's not playing. It's playing on my end.
Oh, no, it's not playing on ours.
No, not playing. Did you use that? Did you click that optimize for video when you shared the screen?
I did not. Let me try it again. Let's see. How do I unshare? Oh, you know what? There we go. Maybe I'm on. Let's see. Is that the way it works? New share. How about new share? Okay.
So
I
this
don't-
hovers and it just kind of hovers there so you see what it sees, right?
Yeah, well, they show it coming out of a base and it flies up. It's very small and it flies around the house. It's by remote control. It's not autonomous as far as I know.
It didn't allow me to optimize.
Are you able to hit play? You able
Yeah.
to click play on? Okay.
Your connection is a little bit spotty, I think, because
There it goes.
And my connection is not good.
Hey, so Jim, this is an indoor.
How about if I just shoot somebody the URL?
I can do it. I posted the URL already. If you want me to try it.
In the chat.
Yeah, it's in the chat. I put it.
Yeah, Thomas, why don't you unshare and then whoever's voice that was, I guess
That's
Jim.
Jim D.
Jim D. Try sharing if you want.
I was gonna do this one.
My internet sometimes is very iffy.
So I misunderstood. I thought it was like Ring and, you know, it'd hover outside and you could see the person or whatever. But is this an indoor robot or drone?
It's indoor. It's
It's like a ring.
Oh, the optimized for video is not available, but
There it goes.
So this is indoor and it's web-based. So you're out in the world and you can fly around in your house and see what's going on.
yeah, that's the idea. Is you could do it remotely.
When Congressman Harley Ruda wrote a bill to stop federal funding from going to China.
That's very interesting. Okay, thank you very much, Thomas.
How long till somebody mounts a taser or a gun on that thing? It's a little frightening.
It's a little frightening from a point of view of the privacy. They
Yeah.
talk about that in the longer video a little bit and the articles, but it's kind of going there really quickly.
Yeah.
But I mean, if someone breaks in, it'll let you know, I guess. But it's my friend Tig was pointing out that it's not that much better than if you have several static mounted cameras that actually have audio and recording, and you could actually shout at somebody through it, or so. But it's a novelty, I think, at this point.
That gets to being able to move around and go wherever. But that having been said, I understand that the rings have been hacked, and there've been issues with, people interacting with kids and stuff like that, that weren't supposed to be, through the ring. So the security is a primary concern there.
Yeah, this
I've
one.
heard that about baby monitors. Heard that several times about baby monitors. I haven't heard it specifically about Ring. But I'm sure it can be hacked.
Ring.
Yeah, they were talking about an advantage is if you're away from home and you want to see if you left the stove on, you could fly around, or if you left something on that you can control remotely, you can see that you don't have a sensor for. I used to have the Rovio is this roving webcam on the ground. So this is the next phase of that.
I had a Rovio too.
That was very useful robot. I mean, I used it from across the country and drove around to do the round.
It was a hassle. It was a hassle to set up, and I think my power supply kept going out on me, and I have to replace it. But it was pretty well done, actually.
Fun for the time. It's pretty old.
They were the folks that made that. They're the ones that made that Android robot. That toy.
Yeah, Wowie produced a bunch of cool stuff.
Yeah.
If I break in and see that drone, I'm just going to steal the drone.
Okay, that's any other robot news out there in the world? Going, gone. Let's move on to club news. Wayne, you want to announce the meeting next month?
Okay, the meeting next month is supposed to be from DJ over at Cynthium. And he's doing robots with easier to use AI than most robots are these days. And that's about all I know. But a number of people in the club know who he is. So they recommended him. So, hey, I can't be too picky.
Thomas Messerschmidt did a presentation on Cynthium at the Robotics Society of Southern California last month.
Oh, okay.
And, pretty interesting stuff.
Yeah, I think people like it. Also, I haven't sprung this on the open robot people, but I'm going to try and get an open robot speaker for November.
Very fine. So the next meeting's October the 28th, and you want to be sure and be there. World-class presentations here.
Mm-hmm.
Any other club news? Everybody got their badges, right? Got to have a badge to get in here. No, not really. There we go. Okay.
Yeah, did you want to talk about the SIG?
Yeah. Let's talk about the SIG. Let's see what I got here. I don't have my notes on the SIG, but we had, what do we have, like 19 people there, and it was good. It was it's the random access and going around. We had some good discussions, a couple of demos. Nothing specific. Did you have something specific you wanted to cover on it?
You're muted. You're still muted.
Let me get a note here. Let's see here.
Yeah, you had such a good decompression that it's all dripped out my ear by now.
Well, let's see if I can bring back up that decompression. Windows 10. I hate it. I really hate it. Did I say that out loud? Okay.
That's
SIG.
something most people agree on.
Okay, we talked about Curly, the curling robot, and there's some let's see. We talked about OpenBot, which Wayne has already mentioned here. And there was some talk about Fusion 360. Hey, Michael Wimble, you're going to be able to do a demo this evening?
No. So besides the SIG on Facebook, I've been talking a little bit about the TEB local planner.
Okay.
And I've been experimenting for many hours a day for several days now, trying to get that thing to work predictably and reliably. And while I've gotten it to work better, and I even understand why it works better, which is better than I've had understanding of any other planner in ROS, it's still occasionally does face plants against expensive furniture in my house. So when I get that all figured out, I will be publishing a long dialogue on how to use that.
Okay,
But
maybe.
I don't have
maybe-
anything for tonight.
Well,
Michael, is that the same
maybe you
thing
can
as
give
a
us
slam
5 minutes of
toolbox?
just, what you're working on kind of stuff. Anyways, hey, folks, speaking of demos, folks that want to do demos, please put in the chat, I'd like to do a demo, and mention your robot's name too, please. Anybody need help with anything in particular? This is another segment that we've just started, what I need help with. So does anybody need help with anything specific robot-wise, strictly robot issues, nothing personal or anything like that? Oh, Rose going to be demoing the Titan. Is going to be demoing that? Is that from the Zany family? Oh, Violet. Okay, very good. And Alan Downing's got the Sir JetBot 1 demo. All right. All right.
Hi, Kemp. I have a question.
Shoot.
So for my next robot, I started printing the wheels and parts for the Swappy robot. And I'm sure some of you over there have already built this robot. And I was wondering if there's anything I should know ahead of time before I start building it. I got the parts. I got the aluminum extruder arrived the other day, and I'm just finalizing the print by finishing up the wheels right now.
Marco, Steve, okay, you out there?
I'm here. So, yeah, I don't know what you used to print the wheels, but overall it looks like the best idea is Patchy for all the pieces. And yeah, it just takes time.
There we go.
Okay.
That's good advice. It takes time.
Yes,
Well, at least I know
400 hours of printing time or something like that.
Do you all advise using the Liwanso, the Chinese cheap actuator?
I use them as steering servos, yes, but I use gear motors as drive motors.
Thank you.
So the my changed pieces are in the official SAPI repository as under modifications Marco somewhere. So that's all there, depending on what you want to do.
All right. Any more what I need help with? Everybody's making them progress. Everybody's working on robots. Everybody's on the main.
Yeah, hey, Camp, I'd like to ask a question to see if anybody's got some super wisdom. I have been working with the Jetson Nano and having a little bit of an issue, in a couple of areas. And of course, we could take it offline, but it's kind of strange because it's the perfect little device to battery power and have on a remote little robot, but trying to run it headless is kind of a pain. And if anybody's running headless and, you know, use GStreamer or whatever they're using to get their video back. Yeah, Phil, I see you raising your hand. I'd like to maybe have a chat. Hi, Alan. So yeah, so that's kind of where I'm a little stuck trying to read all the forums on NVIDIA, and pretty much they're all useless. So.
Did you go through the NVIDIA tutorial? It gives a breakdown on their AI tutorial. It's
well, they have a bunch of them, and specifically, is there one that has to do with running it headless?
Yes.
Okay.
Let me find it and chat the link.
Okay, cool. And also, I seem to be having a problem where I want to run a sort of an ad hoc network on my Ethernet and have my Linux OS sort of bridge the Wi-Fi over to it from time to time. And, you know, I've tried all the, hi Alan, maybe you know how to do it. So
it was amazingly easy.
Really? And I saw the bridge stuff, but I couldn't get it working, so.
No, it was shocking how easy it was. I've been running the Nano. I just got the wireless card and antenna for the Nano yesterday, so I haven't even run it wireless. I've been running it wired, but I don't have wired Ethernet, so I'm basically sharing the Wi-Fi on my laptop and mostly communicating to the Nano via SSH, the terminal box.
Yeah, I can do that. That's so I can ping the from on the Ethernet. I could ping the Ethernet side of my laptop, and I can open up a shell and do all that. But if I want to get internet access and I want to use the bridge of my Wi-Fi on the laptop, I can't get a route correct. And I've tried 10 different ways in the routing table and tried to set it up and then I saw someone says, well, you have to bridge the two adapters. And I'm going like, I don't know. I'm used to, I don't know. I use Novell servers, which you just went into the routing table and you put it in and it worked. I don't know how this works. So.
Now you're dating yourself.
Yeah, I know. They're out of business a long time.
Phil, post the link that you've got onto the chat, and Dan, for sure, post your question to the mailing list. And you can make some progress on that. I am confident.
I just did. It's getting started with AI on Jetson Nano. It includes an OS to flash. It's pretty straightforward. I did everything on a Linux machine. I don't know if it's different. I do robots on Linux and Windows and everything else.
All right, folks. Any other, what I need help with? All right, we're going to go into the main body of the meeting now. This is our 18th annual HBRC challenge, and this is phase 3. Now, the thing about these challenge meetings to me is you work on things that you wouldn't ordinarily work on because you have a deadline. In 2003, a group of us were lamenting the lack of building activity in the club. We knew there were several robots in the club that were just demonstrated once and sitting on the shelf. We observed most building activity coincided with contests. We just had a line following contest, a maze busting contest, but these involve stages and setup and with contests, you always have winners and losers. Somebody was always unhappy. My tape wasn't as shiny, or my maze gates were wider, etc. At the time, we met at the Castro Middle School in Campbell. We met in the library. There were tables all around. We thought, let's do tabletop soccer. We could have a net to catch the robots if they fell, but no, that would be set up. And that's when it was born, the TableBot. A TableBot is a robot that survives, lives, and plays on the table or pays the price. Now, how do you get to tabletop soccer? One step at a time. The idea came out that we would do this in phases. Phase 1 would be to have the robot go from one end of the table to the other and back. Phase 2, push a block off the edge of the table. And finally, phase 3, push the block into a shoebox mounted at the end of the table. We never specified the size of the block, the table, or the box. We never specified the size of the robot. This way people could use the robots that they had sitting on the shelf. We finally And finally, we enumerated that this was not a contest, but a challenge or a show. And here we are 18 years later, having done this 3 times a year. This will be our 54th event. Following 2003, we opened it up to any kind of robot demo and called it the HBRC Challenge. So without any further ado, let's get started with our 18th annual HBRC Challenge Phase 3. Let's see here. First in the list, we have a special guest here. We're going to, Rose, I think Violet's going to demonstrate the Titan, right?
Yes.
Okay, and I think the best way to do this, if you will, do it in speaker view, and that way whoever's, you know, speaking, you get to watch and see, so. And mute your mics unless you actually want to say something, okay? Thank you. Hello, Violet.
I'm 10 and I'll be demonstrating the Titan, which is an Edison robot that I programmed using EdScratch, which is a Scratch-like program using blocks. It uses the obstacle detector, the line sensor, and the speaker in this code. It's going to stay on this, and when it sees an object, it's going to stop and play a little song.
So it's not meant to be a table bot. So we have it, instead of the table, it stays inside the
It's a line follower.
It's a line avoider.
in this case. Oh, wait, is it, did you have your program on it? Yeah, you do. You do. You don't need to program it. I'll show you how to-
So Rose, the robots that you and Michael used to do were the firefighting robots, right?
Yeah.
Yeah.
Now I remember you had the robot that went around the box. You had it following around the box just in ad for them at Robo Games or Maker Faire.
Yeah.
That was very good, Violet. Can you do it one more time?
Close up view.
Very good. That's awesome. Thank you very much.
Mhm.
Violet Chioprini with the Titan robot. Yay.
Mhm.
It stayed in the lines and avoided and stopped at the obstacle. That was very good. Let's see, next up would be Carolyn?
Corlin, do you want to?
Corlin with Robo.
Oh, actually, this is a good. Oh, sorry. So hers is broken right now from falling off the table. So we're sharing robots, so we have to. This.
It didn't survive phase 4, huh?
Yeah.
No. We tried to make it a table bot by adding something. It actually has, this robot has some Lego attachments on the top and the bottom. And so we tried adding some modifications to make it a table bot, but it just wasn't designed for that. So you can explain while I
Its name is Robo, and it's going to go forwards until it sees an object, and then it will back up for 3 seconds and then play a song.
Excellent.
I made it a week ago.
Did you program it?
Yeah.
Very good.
I like the songs and the detector part.
If you can see, I can show you a little bit. So it has a Scratch-based, block-based programming language with it. And both of them have been using Scratch for the last year or so. And so they've also been really involved with Scratch. And so this was an easy, an easy transition for them to then start using those same skills they learned with Scratch to start programming real things.
It's good to see you, Michael.
Good to see you too. All right.
So yeah, you told him what it does? Okay. Wait, can we see it? Try one more time.
Do one more time too. Yeah, do from over.
Oh, well, that's fine.
Yeah, it's fine.
It doesn't matter. Oh, did it turn off? I might have turned it off.
Very good. Thank you very much, Coraline. Good job. All right. Let's move on down the list here. Let's see. Alan, you're next up.
All right. So you can hear me?
Actually, I
So-
think it's Alan Fetterman with the Pi 4 and the Nano, or is that Alan Downing?
I'm Alan D here. I got it.
All right. Well,
He can go first. He's ready. I'll go next.
Go ahead.
Okay. So this is Sir Jetbot the First. So it's called Sir because it was a sharper image robot that I was just walking around a big box store and I saw this thing on clearance for under 20 bucks. So I bought the 3 that actually worked. And and it's been sitting around my house for a couple of years, and I just decided it was time to start playing with the Jetson Nano. So a couple of weeks ago, I started putting this thing together and programming it. So what I have here is, well, this is the robot. It comes with a RC controller, which I disemboweled and put it over here, and on the other side is soldering to attach the wires to the buttons to an I/O expansion board over there. That I/O expansion board is required because the buttons are tri-state logic, and if you want this many tri-state logic things, you've got to use an I/O expansion board. And that I/O expansion board attaches to the Jetson developer kit over here. And that's the guts of it. There's a 2-foot cable that comes up here to a Raspberry Pi camera at the end there. Now, let's see, I'm just turning some stuff on. I don't know if you can see that there's a blinking light there. And yeah. So, excuse me. I think I'll turn it off. Sorry. So I started trying to go through the notebook tutorials that they have on Jetson. They're a really good idea, except you have to have a very fast Wi-Fi. And in my corner of the robot room of the house, my Wi-Fi is not the greatest, and it just didn't really run at all. So I put everything on the Jetson locally. I've got my own Logitech controller here. It stores the pictures on, locally. It has a very low overhead webcam web server, and you can see, and you can still see that there are some of the buttons are oh, I turned it off. Oh well, I won't show off this part right now. But anyway, I have it all running online. I did a poor man's PID, so where it turns on and off the RC so that it can go slower. And when it's off, it will take the pictures. You just run it around wherever you want. It keeps track of what I'm doing with the gamepad, and it stores the pictures associated with that command in the appropriate directory, and then you can train on it. And I've modified it so that it can handle the 10 different types of controls, including the arms and so on. Now, I just got it working this afternoon. To run phase 1 of the table bot. So if I can have a control of the screen for a second.
Yeah, you should be good to go. Just go ahead and share.
You should be good to go. Just go ahead and share. Oh, where's my share button? Sorry, where's the share button on this thing? I don't see it right now.
Should be down at the bottom near the chat.
Chat. There it is. Thank you. Yeah, I got it. I think. Trying to allow it.
Something happened.
Yeah, it's.
Looks like you hit stop video.
I wasn't doing any video. Oh, I see. Oh, come on. It's not paying any attention to me. Okay, now it's popping up. So can you see this?
Just seeing your face at the moment.
Yeah, seeing you.
Huh.
Which is okay.
Can you see it now or not?
Just seeing your face.
I'm sorry, folks.
Maybe flip your camera around.
It said, did you? It's actually, I just recorded it.
Are you trying to share your screen?
I just want to share the screen. Oh, my browser is preventing access to my screen. Okay, well, I'm sorry, folks. Basically, it's just showing the I trained it for about an hour, including the time to generate the images and process the images, and it just goes to one end of the table, slowly turns around, and comes back to the other end of the table. But I'm pretty happy that I was able to get this thing working pretty quickly and painlessly. So
is that a video that you have, Alan?
Yes, it is.
Can you upload it to YouTube?
Yeah, I can upload this, but it's kind of boring. How about if I next month when I'll try to do, let's say, phase 3 of the I'll upload that one.
Go ahead and upload your video on YouTube and put in a link in the chat.
No, I'll do it. I didn't upload it onto YouTube yet, but next week or next month I'll try to get the ARM working as well with the demo. Okay, thanks.
Enough. Thank you very much. Alan Fetterman, are you ready to go?
I am ready. So I've been working with, hi guys, I've been working with 2 systems. I've been working with the Jetson Nano, and just recently, as of yesterday, working with the Raspberry Pi 4. And it's been a bit of an adventure. I mean, I've had Raspberry Pi 2 and 3, and the first hurdle was Raspberry Pi is slightly different in that it needs a USB-C power, which I did not have, and it needs micro HDMI, which I did not have. Fortunately, Amazon comes through in 2 days, So I burned the Ubuntu 20 image on a 64 gigabyte SD card and brought up Ubuntu 20. It was fairly easy. One of the issues is video sync on this is always a problem, and the only way I get the HDMI video out is to first send the video to a Lilliput. Sometimes I have to start and stop 2 times to get it to go to the Lilliput, and then switch over to my big TV HDMI monitor. And once there, the video is stable, but there must be some magic trick to get it to work all the time. I haven't figured it out. So I also got Noetic on there, and I ran the Ubiquity Robotics Magni Robot. They have a good gazebo simulation, and I got it to work, and the kinematics are so good. Turns out we don't have a model for the inertial matrix, so I have Neo working to fix the matrix. So I have a video of that, and I'll show that in a minute when I share my screen. And prior to that, I was working on the Jetson Nano. He's up on Melodic and Ubuntu 18.04 from the Jetpack kit. And this guy took a lot longer to work because Michael Wimble said, hey, you should go and do Jetson hacks. So I went and did Jetson hacks, and it said, here, we can get everything working on all the AI ops working if you follow these steps, but it's going to take at least 48 hours to do everything. So I did all 48 hours. In the end, it didn't work. And then I said, let's go back to the first step. And the first step was, oh, this works on Jetpack 4.2, and I had Jetpack 4.4. So.
Hey, it wasn't me, it was 2 other guys.
All right, no, you said Jetson hack, but I didn't read it carefully enough. So, but actually, Michael, you gave me the first rung of the giant Jenga puzzle. So this now also is working on Melodic, and I got YOLO to work. The issue we're having now is older versions of ROS up to Noetic were all using Python 2, and everything on the Jetson that works is on Python 3. So lots of things that formerly worked on Kinetic and back to Electric and back to Fiorte no longer work on Melodic. An example of that is the ROS Arduino Bridge works fine on Kinetic, does not work on Melodic. And I suppose if I had infinite time, I could figure out why it doesn't work, but I have other fish to fry. So if I could share my screen.
Dan, you got that?
I'm not doing anything. It should just share. You hit the share button in the bottom. It should just work. Famous last words.
There's top one. Okay.
There it is.
There we go.
So this is, I'll first show, this is just a still photo. This is YOLO working off the Jetson. And unfortunately, the Melodic version of YOLO, which I believe you get from something called Darknet Legged Robots, does not work because I think it has something to do with the CUDA version, but I'm not certain. So YOLO works, Melodic works, but things like OpenCV do not work under ROS Melodic on the Nano. And people say, well, the only way you're going to get it to work is under Ubuntu 20. and there isn't an Ubuntu 20 for the Nano yet. So it's like, if we had some ham, we'd have some ham and eggs if we had some eggs on that. So I'm punting on the Nano for now, and then attempting to work on the RPi. So here's an example of the Nano running Gazebo. I'll talk over it. So that's actually showing before I got my Wi-Fi. And this is the Magni Gazebo, and everything's working, including this widget over here. And the kinematics look pretty good. It's working, it's working the way it should. And it actually wasn't that bad getting it to work. I mean, I didn't have very many missing dependencies. It was straightforward. It was a straightforward desktop install, straightforward Catkin install, and away it went. So then for my last trick was, which I actually got working today, was doing the same thing on the RPi on Noetic, but watch the robot when we tell it to go forward. So that's, we have a drunk Magni there, which I think is kind of funny. And, so all in all, some things were a lot easier than I thought, but some things are going to have a high degree of pain. So, for example, on the RPi, I don't have the camera working yet. I don't have OpenCV working yet. Problem is you research it and everyone has a slightly different recipe to get it to work. And I'm sure it works for them, but I haven't got it to work for me. So I can, how do I stop share? Stop share. Okay, that's my, my demo. I don't know if anyone has any questions.
I just, this is Dillo. I just want to say that NVIDIA has had problems for a long time with, there's like this disconnect between the packaging and the out-of-box experience and the actual practical packages that everybody uses, and that really you need to make it kind of a successful product. All the out-of-box stuff on the Nano, or on the, I ran into this problem on the Jetson TK1, and also on the TX1, which is actually kind of how the Jetson Hacks site got started. Is the guy's like, okay, this is all broken, and I'm going to show you how to fix it. But yeah, I run into huge problems with all their boards on. The out-of-box experience works great. CUDA installs with Jetpack, great, and all their demos work great. The minute you try to go away from pure CUDA or away from the NVIDIA applications, try to do OpenCV, try to do PyTorch, try to do TensorFlow, try to do anything that isn't directly an NVIDIA product and hasn't been compiled by them, it all breaks because there's all these dependencies. It's like the two, like marketing and product group is not talking to actual engineering group.
Surprise, surprise.
Marketing guys want the thing to work out of the box and to be seamless and perfect for demos and for conferences and shows and things. And they kind of leave the other guys that are working on the actual packages that we want to use and make it a useful product. They kind of leave them hanging.
All right.
That's
Let's
my
move this thing
experience
along,
too.
folks.
I just want to say that I've been watching, I don't know if you guys know Paul McCorder's Jetson Nano lessons, but they're really great, and he's one of the best online teachers. So you just, Google Jetson Nano lesson and a number, start with 1. And his stuff with OpenCV just kind of works. So if you want to do OpenCV stuff and you want to GStream your stuff, watch how he does it.
All right. Let's
throw in a quick comment if I could, Kent.
Go ahead.
So darknet, there are 2 packages for TensorFlow under ROS. There's darknet, which does YOLO, and darknet ROS, which wraps up darknet and puts out ROS topics and decorate, annotates images and things like that. So DarkNet can get installed as a library and not just an application. There's a configuration parameter in it. So as I wrote in the comments in the chat, if you're interested, I'll show you what I did. So I installed DarkNet as a library, and then I replaced DarkNet ROS, which uses all the source from DarkNet and causes massive problems because of the intermingling of what he's trying to do with the whole YOLO source code. So I just replaced it with a light layer that wraps up the DarkNet YOLO stuff and puts out the interesting stuff to ROS. If you're interested, ping me and I'll see about documenting what you need to do and use my code.
Okay, thanks, Mike.
All right. Say, Thomas, I'm going to interject here a bit. Coming up with Simone's AI by Easy Robot, I've got a few line following and TableBot demos. Let's see, Alan, I think you're still on the screen here. What's going on, Dan? I've got mine set for speaker view. Is it set for speaker view? Can you see me?
You can see
Yes.
we can see you.
Okay, but when I talk, does it come on speaker view?
Yes.
Yes.
Okay.
Yeah.
Cool. This is a line follower. I can't, let me at least see my screen. For some reason, I'm not seeing it. Bear with, oh no.
So for anybody that wants to, you can pin Camp or whoever's speaking, you can pin their video so it just stays on there.
Yeah. Thank you. Oh, there I am. Okay, cool. All right. So this is a line follower QT1. Doing it on a table. I don't know if that counts as TableBot or not. Table's got my tape has gotten a little thick there. Let's get two two for one going. There we go. Hey, it's supposed to be a TableBot. Oh,
I think your TableBot paid the price.
This one, yeah. And he still runs, so he succeeded phase 4. There we go. All right. So there you got 2 line following robots. And QT2 is about to catch QT1. Kind of exciting, huh? There's a little bump and draft here.
Looks good. Yeah.
That's enough of that. Hang on a second here.
Hey, Camp, you ever see those line following contests? I'm sure you have.
The what contest?
The line following contests, you've been involved in those, I'm sure.
Yeah.
I had an idea for one where you put a crisscross in the middle.
Put a what in the middle?
You make a figure 8 with a crisscross in the middle.
Oh, I see.
And you have
So
to have the robot.
This is Nano Turtle here, doing a phase 1. We're hard to impress, but easily amused. So Nano Turtle got phase 1, and let's see if we can do 2 here. This is Whisker's Turtle. This is Whisker's TableBot. We'll push the other one off. I don't want to do that. This is using those flying fish sensors. Dan, you specified those sensors, right? They're digital ones.
You got them working now.
Yeah, they're all right. So that's 2 line followers and 2 TableBots. Thank you very much.
Their special certificate for quantity of robots. I
Thomas,
think you got it.
Thomas, you're on. Thomas Messerschmitt, ladies and gentlemen.
Hi, everyone. So today we're going to try to demo my latest AIML robot chatbot that goes on ARC, they call it. They want you to call it ARC, they told me. I'm going to share my screen and hopefully it shares. Now, one of the nice things about the Easy Robot board, can you see it now?
Yeah, we see it.
Mm-hmm. Yeah, I see it.
First of all, the software is all free to download, so anybody can use this. And they've just started allowing you to hook Arduinos, Raspberry Pis, and such up to it. So you don't need to buy their board. It's easy to configure it for Bing. So I've got Bing configured as the speech input. And this is AimoBot. It's a chatbot software. It resides on my computer here. It doesn't go up to the net. So the Bing is going up to the net because the built-in, and Camp, you've seen this. You saw this last week, right? Anyway, the Bing speech recognition software is, of course, on the web, but you know, Microsoft's isn't worth anything. It has built-in speech synthesis. Hold on. So, can you hear that?
Yeah.
Can anyone hear that?
Yeah, you can hear it. It's not that loud.
Let me try making it a little louder here.
Hello, HBRC. Welcome to my mind.
Can you hear that?
Yeah, that was understandable.
Okay, so right now it is listening, so I can try saying something. Hello? I could say it worked at home, but it worked 5 minutes ago. Let's try. Maybe because I'm going through this interface here. Let me try again. Hello.
Hello.
And again, we may have to wait for next year. Let me just double check my microphone setup. Hello. It just, yeah. Adjust the properties here.
Okay, we've all been there.
Hello? Oh. Hello?
Hi there, sweetie.
How are you?
My logic and cognitive functions are normal, honey. Initiating AIML code. Hi, Thomas. Dear.
How are you tonight?
Fair to partly cloudy. Sweetie.
What time is it?
Do I look like a clock? September 30th, 2028, 02 and 9 seconds p.m. Honey.
Thank you.
You are quite welcome, honey.
What else do you have to say? What else? It sometimes gets hooked up because of this Bing. Bing isn't coming back with a response. So that's kind of the downside of Bing. Tell me about yourself. And then sometimes I have to adjust the properties again.
Thomas,
This is the Cynthium, sorry. Cynthium stuff that we'll have a presentation by DJ Schurz next month.
Exactly. This is exactly.
Honey.
What was your what's your AIML code that you, or what's the gist of it?
You want to see a sample of the AML code?
No, I mean, what is the accomplishment there that you added that?
AMIL consists of like 40,000 lines of questions and answers and partial questions and partial answers and wildcards. And to make it sound any semblance of like a normal person, when you get the blank slate, you have to put in at least 100 hours to get where I am right now. In other words, yes, I wasted 100 hours on this chatbot.
You have to, oh, you talking to it for 100 hour or cumulative?
No, I was editing files and then talking to it to make sure it came back with the right answers.
So why is it adding honey to the end of a lot of this? It sounds like it's coming onto you a bit.
Because I told it to, of course. It's in the code.
Okay.
You want to see the code? Yeah. The code is quite simple. Well, yes and no, the code's simple. The code to augment what I have is quite simple. The AIML code is not my code. It's all open source. It's stored on the hard drive. I'll show you what I did to make it say honey and sweetie and all that.
So is this actively being embellished all the time or improved, that core code?
Not at all. It's dead. It's been
Oh,
dead
there
for
it
more
is.
than 10 years.
Oh, this is old then, I saw.
But it's still a great base for starting. It gives you all the partial questions and the synonyms that people say, you know, because you say to a robot, stop, or stop now, or come on, don't do that. And you got to create an if statement for each individual phrase. But here with AIML, you do all this in advance and you put wildcards in, and you can come up with something pretty decent in a relatively short amount of time. So to say honey, dear, and sweetie, this is the code. Can you see that?
Yeah, it looks pretty straightforward.
Yeah, so the bot response is what's coming from the AIML. That's just a variable. I get a random number from 1 to 4. If it's 1, I say honey. If it's 2, I say dear. Everything else, I say sweetie. Once you see the man behind the curtain, it's just a man, you know, a man programming. Not much either. If you go and look at the Bing code, that's pretty easy too. Every one of these skills, they call them skills, and you get a lot of skills you can add to your robot. And by the way, again, this is free. You can go to their site. You can go to Easy Robot or ARC and get the software and download and play with it. Every one of the skills has a configuration file. And here's the configuration file for the Bing. And basically it's one line of code. We're going to send a phrase to Bing speech. And we're going to send the response to the AIML bot. That's it. That's pretty much it. You've got less than 10 lines of my code to get this to work. And this will do, well, I'm not going to go into it. DJ can show you the rest of this, but this is what I've been working on for the past 2 months to get it to respond somewhat regularly and somewhat understandably, and have answers that match the questions, have answers that are not pre-configured to the prior author of this. They are all, there was a man who wrote the AIML. Everything points to him. I had to unpoint it and put my name in.
So the 100 hours, what was that mostly then?
You want to see the files? I'll show you the files that I added. I mean, yeah, it works out of the box. Oops, I don't want that.
I mean, are you crafting a personality? Is that part of the idea?
Yes. So here's one of them. Can you see the code there? Is it showing up?
I'm not seeing.
Not seeing the code? Hold on, let me share that.
There it is.
Can you read that, or do I need to make it bigger?
Maybe
Bigger would be helpful. Can barely read it.
Okay. Is that better?
Yeah.
So these are hundreds of lines. In a nutshell, you start each question and answer pair with the word, with the tag, is that what they're called? Category, an end category. And then the question is called a pattern. Then you end the pattern. And then here's the response. Pretty simple, right? There's a star for a wild card. Means it'll match everything that says, where have you been, Jack? Where have you been today? Where have you been yesterday? And it'll give this answer. Where am I now? Where am I going? Where am I today? Where am I, Joe? And it'll give this answer. This star here actually will pick up whatever the wild card is and parrot it back.
What language is this?
This is called AIML.
Well, it's XML with an AMI. It's XML. but-
AI, yes, with artificial intelligence markup language. And you can put motor control inside of here. Instead of just saying some words, you can add motor control and all sorts of other things. That's one of the plus points of using this software from ARC. It allows you to read sensors, run motors, and everything else.
That's cool. That's a big benefit.
It has a bit of a decision making, but it's kind of rudimentary. I don't like it at all. There are some people who've done improvements on it. I haven't found anything workable yet. Here's random. You don't want it saying the same thing every time. You give it a list of random things it can say. Where is San Francisco? Where the heart is, where it belongs. It'll then capture the topic, and the topic now becomes where is San Francisco? And it seems pretty simple until you realize there are thousands of these questions and answers.
Kind of a brute force knowledge engineering.
It's kind of like the chess games, where the chess game would calculate every move, possible move, and determine its next move based on that. This is trying to look at every possible question and give you a response. Now, it's not contextual, but it could be. And that's one of the things I'm looking into, is how do I make this whole thing contextual? In other words, we're talking about, say, plants. Well, the answers should come all around plants and not, something else. Or we're talking about robots. It should be about robots. Or we're talking about, schools. We should talk about, things related to that. This is nothing like that yet. That's one of the improvements I'm working on giving it. But again, do we need all these files? I got all the letters of the alphabet. Now that this is grouped this way, there's another, they have other ways of grouping it. And then numbers, and this is a lot of text. I had to break up the W's because that was 1500 KB, and I tried putting it into Microsoft Word, and Microsoft Word choked. It crashed on me. Because I was looking for things, and you make mistakes and it fails. It's look, it even says, who is Ask Jeeves? Okay, Ask Jeeves hasn't been live for what, 10 years, 20 years?
That's old.
I don't know, ask Jeeves.
Yeah, exactly. Yeah, Austin Powers must have been popular back then.
Yeah. All right, thank you very much. Thomas Messerschmidt. Moving right along. Sergey, you want to do your lawnmower debug platform?
Yes, I need to share my screen.
Very fine, Dan.
You keep asking me, but I don't really do anything. You just have to share your screen yourself. There's a share button on the menu bar on the bottom of the screen.
Yeah, once it's unlocked, it's everybody, right?
Yes.
Okay,
you go, it
now
worked.
you should see it, right?
Yeah, we
Yes,
see
we
it.
do.
Yes, we see it.
Okay, so what I'm trying to do, I'm trying to solve a very simple problem of mowing my lawn. And I basically modified my zero-turn mower to work as a radio-controlled car. So you can see it, this is under RC control. So I am standing with the sticks in my hand with the RC control box, and I'm controlling this beast while it is mowing. Obvious problem is that I cannot go straight line. I cannot, scan the area precisely. And it's more difficult actually to control it through radio control box than to sit on it and enjoy the ride. So I obviously have to do it in some kind of automated fashion. But my problem is that I don't want to put the control unit, autonomous control unit, and start debugging it right on that crazed rhino, I actually call this, project Crazed Rhino for obvious reasons. So I started to work on the actual kind of head that I can move between the different platforms. And this is the head, which ultimately will end sitting on top of the actual lawnmower. But currently it is sitting on one of my modified robots that I kind of had for a long time. And now it gets second life as a debugging platform. So what it has Raspberry Pi 3B, and it has a bunch of sensors which I connected to it through different means, I2C, SPI, and I also have a PX4 autopilot compiled for Raspberry Pi, and modified the drivers in PX4 code base to work with my specific set of sensors. So for example, IMU and compass and ADC, analog to digital converter, and stuff like that. So you see my lab after 2 weeks of debugging, actually, all that mess that I created, printing bunch of code and parameters and stuff like that. And the result of the 2 weeks straight of debugging was that I found one single parameter that prevented it from working, moving the servos. You can see those servos right here. But I mean, that's a funny picture for me. I don't know how funny it is.
I've seen worse.
Guys, but
wow, you still print on paper.
Well, I do print on paper and I stick them together and I make big sheets of, whatever information I need. That's in addition to the 3 displays that I have. But I mean, that's my poor brain, how it processes information. This is the same robot, but it is in transformed state. you can see that I made it so that it can open easily, and I can go inside and solder a couple of wires if I need to, and basically work on the inside of the robot. Now, let me see. Here is a short video. It is under RC control in my lab, but the RC control goes through the autopilot. This is the same way as you would control your quadrocopter, for example. There is a switch that you can flip, and it's manual control, and you flip it in different direction, it becomes autonomous. And for autonomous, you have to have a mission. You benefit from, you know, kind of mission programming tool, which I will show you. It is a Q ground control application. But basically, it's very smooth and very controllable under the RC control, and this is what I'm showing here. Now, this is my actual, you know, kind of debugging environment now when I want this robot to go outside and do the mission. What you see here is the ground control station, which is a laptop, and it runs the Q ground control application. You can see that radio box, radio transmitter, and it talks to the radio transmitter, radio receiver here, of course. And there is, you cannot see it, but I mean, you can see a little antenna here. There is a router here, and it provides the local area network, the Wi-Fi network for the laptop. So I basically disconnect from my home network, connect to the router here, and I'm completely having, you know, access to whatever resides in this box here. In this case, it is Pi, Raspberry Pi 3, but there is also room for Nano, and I also kind of fit it there, so I know that when I need it, I will install Jetson Nano in this box, and it will be providing obstacle avoidance through, you know, all the means that it has. And the next couple of slides here. So this is actual crazed rhino waiting for that head to be positioned somewhere here over the driver's seat and taking control. The ground station and the robot ready to run, and now it is running, and this is how it looks like. What I'm going to do is I'm going to point on the map and click on it and say, go there. And then I have to slide that, you know, kind of little pop-up. It is a confirmation means of the Q ground control. And then it is supposed to go from where it is to a position that I pointed on the map, which will be around here. It is around 30 feet from the actual position of the robot. But for a first try, it's a huge accomplishment, you know, so I made, I mean, I spent a lot of time. So this is the video. I'm just shooting it from the phone. I'm confirming the location. Let me show you. This is Q ground control. This is actually SSH running inside the Raspberry Pi on the robot, and it shows me how the things are going there. So go to location. This is where the robot is. It's a little bit shifted, but anyway, I clicked here, go here. So actual positions are somewhere here on the driveway. and somewhere here or as a waypoint
Is this
destination.
utilizing Pixhawk?
I'm not using Pixhawk hardware. The whole point of this project was not buying anything that is kind of running the PX4 code easily. I wanted to use my Raspberry Pi, the standard, you know, out of the shelf, you know.
How are you getting the aerial view?
Pi and stock set of sensors. So anybody here, for example, in this group, can just follow a little bit of, you know, instruction.
How are you Sergey, how are you getting the aerial view?
The aerial view comes from the Google Maps, and it's part of the Q ground control. So this application, the ground station, provides a ground view, the aerial view, by connecting to the Google server, map server, and basically delivering you a map. And because I have GPS on the robot, and because of those connections, all the conversation through Mavlink protocol that goes between the ground station and the robot, the ground station knows where the robot is, and it can upload the mission to the robot, and it can upload the kind of shorthand mission like go there to the robot. I can also control the robot. You see there is that pop down, you know, the armed and hold, and I can disarm it. I can put it in the loiter position, for example, or return position, I mean the return task, or just, you know, mission to start the mission. Anyway, let me continue with this demo. So I clicked on the go here. I'm confirming it through the slide. And now it is moving. It is moving funny because there is some PID. Actually, it is not PID. It is L1 parameter that is completely out of whack, you know, in this particular configuration. And I haven't figured it out yet. So you have that, you can see that zigzag movement here because it tries to kind of catch that track to the waypoint, but it overshoots all the time. And it has to correct, and you know, with IMU and GPS and all the stuff that it calculates. So it's moving to the waypoint, pretty close at this point.
Did you say you have it on like an ad hoc Wi-Fi, its own Wi-Fi router? So it has.
Yes, the router. Let me show you the router here. Maybe. Here is the router. I mean, it is black on black, but I mean, you can see the big router, the 3 antennas, and you can see the Ethernet going into the router.
Yeah, because range is obviously an issue. You know, if you want to stop the robot and it's 30 meters away or something.
For emergency stop of the actual lawnmower, I acquired a different transmitter receiver pair, and it works on a very kind of big range. And also there is an option to use LoRaN lower, it's a long range type of communication. It's not fast, but it's very reliable and very kind of long range.
Cool.
Any questions?
Thank you very much, Sergey.
Thank you, guys.
Yay.
Let me release the share. Okay.
All right. I've got another couple of quick demos here. Am I on the screen for talking view, speaker view?
Mm-hmm.
I don't know why my speaker view is not working, but regardless, here's Buggy. I think people have seen Buggy before. Let's see how he does this evening. Trying for a phase 3. No. Let's try it again. He's a little short of the goal there. Oh, I have to move away. Otherwise, he thinks I'm the block. And the block really has to have surface area. He thinks I'm the block there. There he goes, going for the block. And there he goes, going towards the goal. And he almost got it into the goal. Yay! Let's try that one more time. On back. Well, that's as good as I'm going to get on that one. Anyway, so that's Buggy. And real quickly, if I may, I know everybody's seen this before, but bear with me. My machine intelligence demo. I'm going to share a screen here. This is Rodney Jr. This is how I got started in robotics. Let's see here. I see. So with a differential drive robot, there's 9 possible motion codes, including stop, if you want to consider that a motion code. With Rodney, the primary mode of expression is movement. And so basically what I've got is a Roomba stall sensor with an emitter and a detector. And as long as the little wheel's moving, the robot's happy. Now, Rodney, I should say David Heiseman in the book, How to Build Your Own Self-Programming Robot, he enumerates a theory in machine intelligence that features 3 levels. Phase 1 is random, where the robot just does random motions. Phase 2 has an element of memory, where when the robot is in a particular motion pattern and discovers a response that is successful, that is, moves the robot with magnitude, the little wheel keeps spinning, which is only forward and reverse with a differential drive system. It remembers that, and so the next time it's in that motion pattern, it tries the previous successful response. If it continues to be successful, it increments a confidence level. If it's no longer successful, it decrements the confidence level. And so phase 2 has an element of memory. And then finally in phase 3, the robot generalizes its experience so that when it encounters a stall condition for which it has no successful responses, it tries high confidence level responses from other motion patterns. Rodney Jr. here, I've implemented the same code on a Raspberry Pi. Is basically level 2, where he remembers the successful pattern. So here I'm going to switch the robot on. Initially, it's going to be random, and it will learn responses that maximize magnitude, that is either forward and reverse. So I'm going to switch the robot on. At first, it's random patterns, and then eventually it'll learn forward and reverse. It's not that the robot goes forward and reverse, it's that it's learned to go forward and reverse. So when you see the red light there, it's not happy, but when you see the green light, the robot's happy. So you see the robot now is going forward and reverse. It's not that it's learned to go forward and reverse. It's not that it's going forward and reverse. It's that it's actually learned to go forward and reverse. Thank you very much.
What's the name of the book again, or the author?
Oh, it's How to Build Your Own Self-Programming Robot by David L. Heiserman. Heiserman wrote a lot of those tab books of the 80s, in the 80s, and this is one of them. The original book that I got started with in 1982, he would have you build a 8085 microprocessor controlled device from scratch with an 8-bit data bus and a 12-bit address bus, program it 1 byte at a time in binary. Yeah.
I have that book, Cam.
Sorry.
I have that book.
Oh, How to Build Your Own Self-Programming Robot by David L. Heiserman.
Yeah, I know. I have it. I have it.
Okay. Yeah. After about 5 years of wrestling with this, I finally implemented the machine intelligence theory on an IBM PC with a Relay IO card, and that was a eureka experience. All right, so moving right along, let's see now. We've got Beach. You have a small robot. What's your robot? Oh, the PyBot?
Yes, sir. Can you hear me? Okay?
All right.
Yeah, can you hear me?
Hello.
Oh, not sure you can hear me.
I can hear you.
We can hear you.
We can hear you.
Okay. Sorry. All right. So, Camp, this is going to look a lot like yours, but I promise that I didn't see yours first.
Homebrew style.
So I basically got the battery and built the box, designed it and printed it, and so every time I needed something, I just basically printed it out. So it's a Raspberry Pi Zero with just an H bridge, and then I just started cramming stuff on until the sensor pins were full. I actually still have a few pins left, but yeah, it's so I was gonna do phase 1, but I'm gonna have to switch cameras. Would that be okay?
Yes.
All right, cool. Give me just a second here. Can you hear me on here?
I like your terrarium.
Yeah, it's a Mac, an old Mac.
I see that.
Oh, let's put my camera on here.
Bless you.
There we go. So my wife's asleep, so I'm just going to try to do this.
Yeah, can you unmute yourself on your phone? Your phone is muted.
Okay, thank you. Can you hear me now?
Yeah.
Yes.
All right, cool. Perfect. Let me make sure he's on. This won't take long. It might go right over the edge. So.
Awesome.
All right, so I built a web interface for it. So I'm just going to launch that real quick because I was running back and forth to do this. Okay. Here we go. And nothing. Here. Can you guys see this?
So you've got those flying fish sensors too.
Yep. Obstacle avoidance.
Yeah, we don't see anything while you're in your browser. Zoom has to be active.
Geez, it just finished. Let me do it again. Hang on. All right, hang on just a second.
Oh, sure, it worked when the camera was off. Sure.
Hang on, let me stop it. Stop. Here we go. Sorry. Okay.
Of course.
Can you see me now?
Yes.
All right, cool. All right, so I'm gonna turn on and flip the camera back.
Huh.
You see him?
Yeah, we see him. He looks great.
Okay, phase 1. I'll send you my address for my certificate, okay?
You bet.
Just kidding. So I got the NeoPixel on the front there just because I had a little bit of time, and like I said, a bunch of sensors left over. So I'm gonna implement the sonic sensor and do some floor-based stuff. So
What's the, I'm sorry, what's that cliff sensor that everybody's using?
that's an obstacle sensor.
Just IR.
It just, you notice when it senses the edge, the light it basically sends a signal that it's, noticing a depth. That's all I did.
Is it a particular, I mean, is there a name for that?
Flying fish. It's from Amazon. I'll post a link.
What, say again? Okay, post.
Flying fish. They don't. It's yeah. It's Pride of China. Oops, I don't want to buy it again. I just want.
What was it, Camp? Was it like 10 of them for $8? Something like that.
Yeah, you know the deal.
It's really cheap.
And yeah, here we go.
Yeah, I used some Pololo sensors before. They are not quite as cheap, but they work as well.
Well, if you need 4, you can buy 10, and probably 4 will work.
Yeah, Jim, you got. I posted the link there.
Wow.
Thank you very much, Beach.
Got it. Thank you.
Yay!
Okay. Does anybody else have demos? Put it in the chat right now. I've got one right now I can show you. I've got. Am I on the video when I talk?
Yeah.
I don't know why mine doesn't. I got speaker view for everybody but me. Anyway.
I have a hi, this is Dillo. I posted a video link or a link to one of my latest drives outside at circuit launch of my Tenacity rover.
Yeah, go ahead, Dillo.
Do you want me to go ahead and just share my screen?
Yes, please.
Okay. Let me see if I've got this here. Give me a second. I'm gonna have to step away here and see if I can get it
I'll
up.
catch up with my floor bot in the meantime.
Yeah. You know what? I think it might work best if I download it and then display it.
All right, you're on board the floor bot. I mean, you're on board the Zoom bot here, and I'm chasing down the Nito turtle. There he is. I'm running some code I call floor bot. See if I can see him. There he is. There he goes to the next location.
Okay.
Dart the cat and the Nito turtle are having a standoff there.
Okay. Let me see here. Okay. So I can share my screen and show you the video from
Go
my
ahead.
screen.
Oh, wow.
Okay, so this is my SWAPI based rover Tenacity. We're just coming back inside at circuit launch, having spent about an hour or so whirling around outside. This thing where my cursor is, that's a GPS. So it's a GPS GNSS system, and there is an IMU. You might get a better glimpse of that in a minute. So I'm teleoping this right now, just trying to get it back inside and lining it up for the elevator. It does right now the kind of the sort of the state of the bot is that it does what I call a directed tele. There's some software I wrote that does what I call a directed teleop, which is I push a button on the joystick and it goes forward until it encounters an obstacle, and then it stops, and then it waits for me to like drive it a bit or tell it, you know, push the button again and it goes forward, which is kind of a lot like how the real Mars rover works. The one that's actually on Mars is the guys at JPL, they upload a program, a navigation program, like, you know, hey, we want you to go over to this rock, and the rover moves over there, and if it encounters an obstacle or if it hits some sort of, you know, violates some sort of safety condition, it stops and waits for somebody at the other end to tell them it's okay, you know, to tell it it's okay to keep forward. So I'm kind of emulating that, but this right here is just pure teleop. So, and that's inside a circuit launch in Oakland. That's the space that I've been building this rover at for about the past year now. So I got that. And then I think I got one more here. Open file.
Great work.
Yeah, thanks. Steve's vid, testing and circuit launch. I think that's it. I got, actually, you know what? I can exit full screen here. Let me just stop sharing. And just hold on a second here.
Side note, if I may, folks know that you can save the chat by clicking on the ellipse on the right bottom.
Mhm.
And there's an option there to save the chat if you want to save the chat on your.
Okay. I have one more. I've got one more if I can. Okay.
No problem. Go ahead.
So this is from yesterday. More roving around outside yesterday. I have the audio, so it gives you a bit of an idea of the scale of the rover. Oh, and the addition, so like the one that I did with going in and out of the elevator from a couple weeks ago, this one is from yesterday, so you'll notice that there is a little green blob on the top there where there wasn't one before. That's a Jetson Nano. I'm just getting that kind of shaken out. Getting it integrated right now onto the robot. Currently, the robot it's all being run off a Pi 3 and an Arduino Mega 2560. But I'm getting to where I want to start doing some kind of better, more complicated image processing, and pretty much anything having to do with anything other than like processing stills off of the Pi camera on a Pi 3 kind of squashes it flat performance-wise. So the Aster cam that I have hooked up on there, which is a depth cam, you try and run the Aster cam node, ROS node, on the Pi 3, and it just kind of goes.
Not on the Pi 3.
Yeah. So I'm going to be moving over for actual like machine vision. I'm going to be moving over to a Nano. Pi 3 has been great though. It's a great little board for running ROS. It runs the whole robot right now.
Yeah.
Can't complain. You know. So yeah. So that's pretty much my demo. I still kind of like testing things and breaking things, so I haven't gotten nearly as far as I wanted to, but yeah.
Yeah, if you want to see more SAPI, I have put 2 links in the chat. So just for fun. Not much new there.
Speak up.
I have put 2 more SAPI video links into the chat at some point. So, but yeah, not much new on my side right now.
All right. So let me, I'm going to share a screen of the map that I made. This is the map I've made of the house. And I'm running a program I made called Floorbot. Again, the Nito turtle is just going round and round. There it is. I think he's done like 4 or 5 laps now, just going around the house. This is, as everybody knows, the SB-ROS Intro to ROS package. And by the way, I've joined a AI MI, Artificial Intelligence Machine Learning group that meets on Sundays through Skype. And it's interesting because they had planned on doing, it's ROS 2, they're trying to do ROS 2. They had planned on doing the Mushi platform, which is like an RC car with Ackerman steering. But that blew up because I understand there's not Ackerman steering transforms in ROS 2. So I think I may have shanghaied them and convinced them to try and do it on the BotVac using the SB-ROS Intro to ROS package. Now, James, I understand that you've upgraded the Nito driver and the wrapper Nito.py to Python 3, which is the starting place for this, right? James Nugent, are you out there? Anyways, I'll send a link. Like I say, it's an AI ML group that's interested in ROS 2. And I might have gotten them to focus on the BotVac and the intro to ROS and maybe bring that into ROS too. So that's kind of exciting. So he's trying to get his, I think this is the third waypoint. I won't linger here too long. This is the BotVac with a Raspberry Pi 3. And as everybody knows, the BotVac features a two-dimensional LiDAR. I actually have a PiCam on there and a voice synthesizer too. So this is where we were before. So he's made like a half a dozen circles, loops around the house. Let me show you a few other things. Oops. So he comes to the fifth waypoint. As soon as he settles in on that, I'll show you the voice synthesizer. All right, goal reached. You can applaud. All right, so this is the BotVac, and let's see here. Can you hear that? Yes?
Knock, knock.
Yes, yes. Bear with me. This will be totally worth it. Bear with me.
Who's that?
I think I just blew the punchline. What the? Bear with me. I was trying to get a laugh out of him, but it doesn't seem to be taking. I'm going to try it one more time. Let's try something different. Anyways, I've got a Pi Cam on here also, and you heard some of the voice synthesizer there. And then finally, you might recognize, let's see if I get it here. Here's Loco Go. This is Nito with the Turtlebot 1 superstructure and the ultrasonics. And I've recently gotten a Turtlebot 2 superstructure, and I've got the Astria camera there, and I actually have some images from the Astria camera that do come through Ross. Let's see if I can find that.
Camp?
Yes.
That's the same cam, the Aster cam that you've got there? That's
Yeah.
the same one that I've got on my Rover.
Okay. Very fine, very fine. This one's, I think, 150 bucks.
Yeah, they're pretty cheap.
Yeah. So I do have some images from it. 3D images. Actually, I'm at a point where I prefer the Turtlebot 1 superstructure because it's lighter. But anyways, I do have the, I'm starting up another one. I've got a Raspberry Pi 4, and I'm kind of psyched to get this thing going. The end game for me is what I call the smart table. It's basically like a TV tray that can get from one place to another and back again in an unstructured environment. I think that's useful. All right, do we have any more demos this evening? Did I miss anybody in the chat? Any more demos? Speak now or forever hold your peace.
Hey, Camp, it's not a demo because I couldn't get it working, but I'd like to show my progress at some point.
Show your progress, Dan Alberts. Dan Alberts, ladies and gentlemen.
All right, yay. So I don't know if you guys can see the last time, last month, I showed you the base of the robot, which is this thing here. You can buy that. That's a quadruped, very similar to what you see from Boston Dynamics. What I've got here is I've been really working with my 3D printer, and I've got the whole power supply and I2C servo controller inside here. And then I've got a gantry system that controls the head and the head inside. Whoops, that shouldn't have happened. That's my backdrop so you can see what was going on. It actually
Nice.
dropped. Yeah, nothing like a backdrop dropping.
And inside the head, normally I would have this, but right now, until I get things working headless, the head won't have the camera in it. But it is 3D printed and it fits in there and everything, and it's kind of all wired up and everything. Really, the power system works fairly well, and you know, it's all good, and it's, you know, next month I hope to have it, you know, obeying commands and sitting and jumping and all that stuff, which will do remotely, but it won't do it yet through, you know, the AI stuff. I want it to be able to, at some point, be able to say heel and have it look at me and be able to walk around side and stand next to me and then sit and then, you know, maybe do other commands that a dog might do. So
Our plans for total world domination is coming together nicely.
Yeah, well, I want to have the first robot dog that can actually pass an obedience test with the AKC and just see whether or not they will accept the robot dog as a breed. You know, we don't know yet, but it's coming.
That's awesome. That's awesome. Thank you very much, Dan. Thank you.
Thank you. Yeah, next month will be better.
Very good. Onward and forward. Any more demos this evening? Come on. I know somebody's got one. Any more demos this evening? Well, I would like to thank everybody for being here, and especially those who have participated. We had 40 people online at one point, and there were 18 robot demos. So I do believe we've had another successful HBRC challenge, our 18th. And so let's keep this going. Let's keep building robots. We always have show and tell, and looking forward to next month's meeting. So what do we got? 12:05. We've been at it for 2 hours. Why don't we just let it go for random access for saying 15 minutes, Dan? Is that okay?
Yep, sounds good.
All right, we'll just turn it over to random access for 15 minutes, and then that'll be it. You have to go home. Well, you don't have to go home, but you can't stay here. Thank you very much. Had fun. Let's see if I get my robot laughing. Which one? Ross Nito. Let's see here. Why did that work?
Yeah, you're using eSpeak for that?
I'm sorry, what?
You're using eSpeak for the...
Yeah, it's eSpeak.
That's good stuff.
Meow, meow, meow.
That's the robot talking. Let's see if I can get the ha 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 now. Is that what you have? What are we calling it?
eSpeak.
Well, I use eSpeak. I was trying to think of the name of the voice box, though. It's Audio Rasp or something, Audio Raspy or something.
No, I'm not
this
sure.
This is eSpeak.
I'm trying to make a pumpkin. You can really work with that voice and make it sound pretty scary.
Yeah. Is that working? Let's try something here. I don't know why that one screen just goes kaput.
I am a robot.
Interesting. Everything seems to work but the laughing. He's in a serious mood.
Beep, 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 boop, beep, goo, weep. Beep, 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 boop, beep, goo, weep.
Yeah, that's what he said. So like I say, I'm with this AI ML group, and they wanted to do the Mushi. I'll post a link to the chat. They were trying to do Mushi. There he goes. But as I understand it, ROS 2 doesn't have an Ackermann drive transform. So I postulated the Nito BotVac in our Intro to ROS base. And James Nugent, are you out there? I understand he's already updated the Python code to Python 3, which is the starting place to moving it over to ROS 2. So that's kind of exciting.
I am a cat.
Let's see here. I'll find this Mushi platform. Oh, I need to find it on this computer though. So the Cynthian thing is going to be interesting next week, but those guys are so intertwined with Windows, it makes me queasy.
And it should.
Hello?
What? Who's what?
It should make you feel queasy.
I know, it makes me feel queasy.
Windows crashes a lot.
Well, Windows is ROS 2 now, so I mean that's part of the deal. Making a deal with the devil. Let's see here. How do they spell that? Okay, I've got a. Okay, let me see where the recording is because not that. Chat. Okay, where do they save the chat? Dillo, we'll see you next time. Let's see here.
Take care, everybody. It's great to
All
see
right,
you
buddy,
all
have
again. See
fun.
all your robots.
Thanks for coming.
Not a problem.
Thanks for participating. Let's see here. Documents. Zoom. And see if that's it. Chat. No, that's a different one. No, was that? It's kind of interesting. You RSSC guys. I think somebody was at the somebody else was at that ROS 2 meeting, weren't they? Or somebody? Jim.
Can you hear me now?
Who is that?
It's James.
Who's that? Oh, James. Yeah, I can hear you now. Were you out there all the time?
Yes.
Okay.
But my mic wasn't working again in Windows this time, so I don't know what's going on.
It's not one thing, it's another.
Yeah.
Let me hunt up this group that I've joined on Sundays. That's a ROS 2 group. And I'll look at my email. Maybe it's in there. Oh, I know. I can go to the meetup. Let's see. But these guys were trying to do they tried to do ROS 2 with this RC car-based platform, but ROS 2 doesn't have Ackerman drive transforms. So I may have shanghaied them into applying their efforts to the Intro to ROS package. And I did mention that you had already, converted the driver and the wrapper to Python 3, which is the starting place, right?
Yep.
Yeah, so, here it is. Good. How was this event? This event was excellent. Okay. It's machine intelligence and machine learning for robotics. These are software guys. They're really steep into AI and machine learning and stuff, but they're coming up to speed on hardware. And I'm just going to post this meetup link. It's all I got right now. And I want, yeah, there you see a picture of that Mushi car, and it's using Intel depth cameras. Ah, here it comes. That's there. Chaz. Chaz is the guy that leads the thing. He's from France. Let's see. Still can't find a. Bear with me. That's their GitHub. And I want to find something about that car.
It's called as Musher, right? Musher, right? Musher.
Do you know of it?
I have. I joined that meetup, and I think he was mentioning about Musher, Mushr, or something like that. Let me find that out.
All right. All right.
Musher.
Yeah, it's mushr.io is the website.
There we go. Bingo. Okay. So they all had this full head of steam. You know, they were going to port this over to ROS too, but it's kind of a screeching halt. I'm going to do my bot vac demo for them on Sunday. And I think that converting our intro to ROS, I should say, the SV ROS intro to ROS package to ROS 2 is much more doable than what they were attempting to undertake. So yeah, you see the meetup there, the link. That's Dr. Ed, you were there. Were you at that meeting?
Yes, I was. I was
Very
the one who
fine.
remembered James Nugent.
Yeah, you were the.
James, it's my fault.
Yeah.
That's okay.
Yeah, yeah. So that might be a good one to show up for. And let's
Put the link in the chat so
intro-
people can click on it and see what the last meeting was like.
Yeah, yeah, very good. All right. Well, we've taken 15 minutes now of random access. Does anybody have anything they want to say before we shut this thing down? It was fun. We had fun. When's the next RSSC meeting? Thomas, do you know? You guys do? Go ahead. What do you do, like first and second Fridays or something?
Second and fourth.
Second and fourth Fridays. That's the Robotics Society of Southern California. And you guys have show and tell every time too, don't you?
We have show and tell every time. Yeah, that would be the 10th. Next one's coming up on the, 9th of October.
Very good.
We start at 5:45.
Very good, very good.
Pacific.
Pacific time.
Yeah, not where you are, Cam.
I'm getting better and better at this. All right. Well, we had fun and it was informative and this is good stuff. Again, I want to thank everybody for showing up and especially those who participated. It's very good. And let's build robots. We're a robot building club. Our stock and trade is functioning robots. Works in progress are good for partial credit. Thank you very much. All right. I'm out. We'll see you guys. See you. Love you. Take
See
care.
you next
Bye-bye.
time.
Okay. Good job, Camp.
Thank you, Dr. Ed.